now in lesson 6.1 problems when we have variables in them and but we still can do some simplifying. So here's a reminder. And I'm not sure if I even really said this a whole lot, but even if it isn't a reminder, then it's the first time. An expression is not simplified if it has 0 or negative exponents in it. So you've got your answer, you think you're done. If something is still to the 0 power, it's not simplified. If something is still to a negative power, it's not simplified. Now notice I did not say, because I already know some brains in here are doing this, and then I know there's some brains that aren't even tuned in yet. There are some brains in here that just heard me say, if you have a negative in your answer, you're wrong. It's not simplified. Is that what I said? What did I say?
If the power is negative.
If you have a negative power, it is not simplified. You don't get to quit until all exponents are what?
Positive.
Positive. They can't be 0, they can't be negative. Okay, so we don't quit until we have that rule. Okay, number 1, m to the negative 2 power. Can we simplify it?
Yeah.
Okay. Because, and why do we have to simplify it?
Because the power is negative.
Yeah, because it's to a negative power. So we actually we do have to simplify this. When something's to a negative power, does that make it a negative?
No.
No, what does it do, Isaac?
It makes it a fraction.
Makes it a fraction. So what's the fraction for this one? Brighton?
1 over m to the second power.
Okay, 1 over m squared, or to the second power. Okay. Is it simplified? How do we know? What are we going to look for? How are we going to know whether this is simplified or not? What are we going to look for? Ian, can you tell me? Do you think it's simplified? These guys up here, you know, my 2 in the front that I get to hear from all the time, they said it's simplified. Do you agree with them?
Yes.
Okay. Do you know what's going to convince you and the others as they're working that it is simplified? What's the reason? Cameron, what's the reason this is simplified?
Because the exponent is positive.
The exponent in it is positive. Okay, the exponent is positive. There's no other negative exponents. There's no 0 exponents. We don't have a fraction within a fraction. By the way, things aren't simplified when you have a fraction within a fraction. Which, do you remember that problem yesterday where we had 1 over 1/4? Is that simplified?
No.
No, because we got a fraction within a fraction. So that's not simplified either. Okay. Then that one's done. We're going to circle it and say, there's our answer. Okay, number 2. Do we need to simplify number 2?
Yes.
Okay, tell me why, Josh, we need to simplify number 2. You don't know? Is that what you said? Okay. So, but you are engaged with me, right? Okay, Stefan, why isn't this one simplified?
Because the power is negative.
Because the power is negative. Okay, what is being taken to the negative power in this? Stefan?
X.
Just the x, isn't it? Why isn't the 2 being taken to the negative 1 power? How do we know that the 2 is not being taken to the negative 1 power? This is important that we understand this. How do we know that the 2 is not being taken to the negative 1 power? Trey?
It's not in parentheses.
It's not in parentheses. If we had 2x in parentheses and the negative 1 power outside those parentheses, then both of them would be. But in this case, only the x is taken to the negative 1 power. So what does 2 next to x to the negative 1 power mean?
2 times x.
2 times. So we're going to change this to 2. We're going to insert a multiplication dot. How can I rewrite x to the negative 1 power? How can I rewrite that one? JC?
1 over x to the negative 1 power.
Or, I mean,
not
oh, not negative, yeah. It's had some people that were ready to disagree with you. So 1 over x to the positive 1 power, okay? So what do you think we should do next here, Brighton? Or did you have a question?
Can't we just leave the 1 out of it since it does basically nothing?
Yeah, could we ditch the 1 when it's up to the power of 1? Because when something doesn't have a power written up, it's not written as a power, what exponent is really there that we just don't show?
1.
It is always 1. So we're going to take this now and we're going to change 2 into a fraction by putting it over 1. We can get rid of that exponent of 1 only because we don't need it. And now we have a fraction times a fraction. What do we do when we multiply fractions? Mia, what do you do when you multiply fractions?
Simplifying.
You simplify if you can first. Is there anything that would divide into a numerator that would also divide into a denominator here that would make it worthwhile to do? Because if it's just 1, it's not worthwhile to do. So do we have anything? No. So if we don't, then what do?
Multiply it from across.
We multiply across. 2 times 1 classes?
2.
2. 1 times x is
X.
x. Do you think we have it simplified?
Yes.
Okay, give me reasons why. Ariel, what's one reason that you think that might be simplified?
Because there's no exponents, like negative exponents.
There are no negative exponents. Okay, that's one of the reasons. What's another reason this is already simplified, right?
It's in its simplest form. It can't go down.
How do we know that? That's what we're trying to answer. How do we know it's in its simplest form? And you are right, it is in its simplest form, but one of the reasons is because there's not a negative exponent in it. Another reason, Cameron?
2 can't go into X. They're 2 separate
Okay,
things.
there's 2 and there's nothing that goes into 2 that also goes into x, that we could simplify that. Okay, give me another reason. There's still a couple more reasons. What else can't they have? Well, we already said it doesn't have a negative exponent.
0 exponent.
Can't have a 0 exponent. Does it have a 0 exponent?
No.
No. Okay, feeling good about that then. And then I also said it can't have a
Fraction.
fraction within a fraction. Do we have a fraction within a fraction?
No.
No. I'm feeling good about our answer, but I think we get to stop. So my point is going to be this. Here's what you're going to want to do, because you always want to get down to homework as quickly as you can. And you're just going to come up with an answer and stop, but you need to run through those tests. You need to say, is it really done? Because these are tricky, okay? And they get trickier. Okay, so does anybody have any questions about that one? Okay, number 3. A to the 5th, b to the negative 8 power. Can I simplify that?
Yes. You're gonna have to.
Okay, so Isaac says I can. Why do I have to? What's the reason I have to, Isaac?
There's the negative, it's a negative b. You have a negative power.
Okay, can't have a negative power. Okay. Is a to a negative power?
No.
No. That one's not to a negative power. Brenton, what do you think?
Just leave it.
Leave it, yeah, don't mess with it.
Work on B.
Yeah, work on B. So a to the 5th, we're going to just leave it. We're not going to mess with it. And then a to the 5th next to b to the negative 8 power means multiplication. So how can I rewrite b to the negative 8 power? JC?
Over b.
Okay, I gave you another chance, so this time you would say it right where right? You did. 1 over b to the 8th. Okay, what are we going to do with that a to the 5th?
Leave it.
No, put it over. Because now we got a fraction, so we got to multiply fractions. So we're going to stick it over 1. And then, by the way, do they have the same base, these two powers? A to the 5th power and b to the 8th? Do they have the same base?
No.
No, one is base what?
A.
A, and the other one is base
B.
b. So yeah, that's, okay, so we can't do any simplifying. B's can't be divided into A's and A's can't be divided into B's. So we're going to say A to the 5th times 1 is
A to the 5th.
A to the 5th. 1 times B to the 8th is
B to the.
B to the 8th. Okay. Are we done?
No.
No? Okay, what do we have left to do?
Check it. If we have anything.
Yeah, we gotta run it through the test, okay? What do you think?
Doesn't
Are there any negative exponents?
No.
Are there any 0 exponents?
No.
Is there anything that can divide into upstairs that can also divide into downstairs?
No.
No.
No. Is there a fraction within a fraction?
No.
No, we're done. Okay. Okay, how about you try the next one on your own? You've got all, you know how to do it now. We've done a couple of two or three problems, we've done 3 problems here that should help you out. Does that -3 need to be renamed because it's negative? No, it's not to a negative power. It's just a negative number. Leave it as it is. But we have to rename x to the -2 power, right? Because it's a negative power. We have to rename the y to the -3 because it's a negative power. So it looks like we have fractions to multiply with, so we'll put our -3 over 1. Anything we can do that can be done upstairs and downstairs, the same thing that will, before we multiply? Any simplifying before? No, so we're gonna say -3 times 1 times 1,
-3.
-3. 1 times x squared times y cubed.
1x cubed y, 1x.
Do you think we need the 1?
No.
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 It's x to
X not 2,
x squared.
x squared
Y cubed.
Y to the 3rd or cube. This is a y to the 3rd there. Okay, now, how you feeling? Think we're done?
Yes.
Run it through the test. You can just run it through the test yourself without saying it out loud. Does it pass the test to say, I'm done with this one? Okay, all in favor, they think this one's done. We can't do another thing to it, hands up in the air. You're right, we can't. But I'm gonna tell you one thing. Are they gonna show it in the answer bank this way, do you think?
No.
How are they gonna show this in the answer bank, Josh?
-3 over squared y cubed.
So the negative is still gonna stay with the 3, is that what I heard?
It's gonna be next to fraction.
Oh, yeah, so we're gonna make the fraction negative. Remember, when one of them is negative, we pull it out and we do this. So that's how they would show it most likely in an answer bank. Okay, so we just wanna make sure that we were really done here. We were done. There wasn't another thing we could do. But let's call this cleaned up. This is how we would see it in an answer bank, most likely. We have to know that we have the right answer when they don't look exactly the same sometimes. Okay. I think you're gonna like the next one because I'm gonna make it really easy for you, okay? I can complicate this one, trust me. But it's almost Friday, so why? Okay, so let's see if we can make this easy. Anybody think they know how we can make this easier compared when you think about some of the things we talked about earlier in the week and done in our notes earlier in the week, right?
Can we just take away the division bar?
Just take away the division bar?
Just take it away.
Just take it away?
Wait.
What am I gonna?
Can we do it in steps so we do the first one first and then the second one? I mean the one on top first and then the one on the bottom.
Okay, we could. But, yeah, what would we create? Because I'm seeing negative exponents upstairs and downstairs. What are we going to create? We got a fraction to start with, don't we? So Malcolm, do you have any idea? What's...
You gotta remove the negatives.
Gotta remove the negatives. How can we remove the negatives? There's a really easy shortcut we can take to removing the negatives. Do you know what that is? Brighton?
Flip the problem around where 4 times x squared is on the bottom and the 4th is on top.
So when it's a negative power, it can just move downstairs and become positive if it's upstairs. And if it's negative downstairs, it can move upstairs and become positive. But Brighton said one thing that we gotta be careful of. He said, take the 4m squared and move it downstairs. Do you think the 4 should move, Stefan? Why? Yeah, the 4 isn't being taken to the negative 2 power, is it? It's not in parentheses with that m, is it? No, so the 4 is not being taken to the negative 2 power, so that's not going to move. It's staying where it's at, so leave me alone. You don't need to mess with me. So here's what we're going to do. We're going to make it this easy. We're going to say, there's really going to be no work to show for this one. Okay? We're going to, well, basically we could show this, that these two right here, this and this, are going to trade places. Okay? They're going to trade places. So, what's it going to be? 4
And to
n to the positive 4 power over
and to the second.
m to the second power, or squared. Right. There's a whole bunch of stuff we could do that would be really applying all the properties, but you know what? Sometimes we can be into shortcuts, and there's a shortcut. Okay. For all of you going to be math teachers, I'll help you do that sometime. Okay. What do you think we can do in this next one? Any ideas? You can just give one idea or a couple of ideas, whatever. What do you think, Rose? Is there something we can do? You got an idea for that next one?
Could you just add the whole numbers?
Add the whole numbers? You mean like put it together? It's really 5 divided by 7. Think we can do that? But you can't, but it was a good thought for a bit. But was there anything else you wanted to try? No? Okay. How about Marky, can you come up with something for me? Seth, can you come up with something for me? Josh?
A would be 1.
8 to the 0 power would be 1, right? Yeah, 8 to the 0 power would become 1. So that would be one thing we could do. Okay, so let's say 5 times 1. We're replacing the 8 to the 0 power with 1. Anything to the 0 power is 1, even A's. Stefan?
Okay, so the b has a negative 2 power, so you can take that down. Just the b, negative 2 power down, so it will become b pot to the.
So you want that to move downstairs like this? Is that what am I doing? I don't know what that was about. Okay, I'm going to erase here. Just give me a moment. Okay, so you just want the b's to go downstairs and become a positive 2 power. Is that what I just heard?
Yeah, so downstairs it will be 7 c b to the positive.
Oh, so you're saying we're going to leave the 7 and the c down there?
Yeah,
Okay, why?
because
Because they're positive.
They're both positive to the, not because they're positive, but because they're to a
positive
One
power.
power.
positive power. They're not to a negative power. They're not to the 0 power. 7 needs to stay where it's at. C needs to stay where it's at.
And then 5 times 1 will be, you can take away that 1 because then it
Yeah.
becomes
5 times 1 is
5.
5. And 7 times C times B squared. Remember algebra. Remember algebra's it's got these crazy, like its own etiquette. It says let the constants be first in multiplication. And then if there's more than one variable, put them in what kind of order? Alphabetical order. So what would we do?
B.
7 first,
B squared.
B squared, C, because B's are before C's. And then we ask ourselves, are we done?
Yes.
Okay. Now, Rose wanted to do something with that 5 and 7, and it's good to think about that 5 and 7. Can we do anything with it? Well, we only can if there's something that divides into 5 that also divides into 7, other than 1. Is there anything other than 1 that divides into 5 and also into 7?
No.
No. So then we're just going to leave it as it is, okay? So, do everybody think we're done? Does it pass all the tests?
Yes.
Okay, then, here we go. And no cleaning up needed there, there were no negatives hanging out anywhere, so. Okay. I think this next one, we'll just do this. We'll insert some multiplication dots right into the problem. And then we'll rewrite it as a multiplication problem, doing any simplifying steps along the way we can. How about 3/4? Did you do anything with 3/4? Okay, so we're gonna leave it 3/4. How about r to the negative 2 power? Should we do anything with that?
Yes.
Okay, what should we do with that? Riley, you got an idea for me?
No.
No? Okay. Rose, you got an idea for me? 1/r², is that what I heard? Okay, I think that's a good idea. 1/r², because it's to a negative 2 power, so it becomes a fraction. Okay, p to the 3rd power. Emerson, what do you think? Think we should do anything with p to the 3rd power? Pardon? Okay, what fraction should it be then? 1/? Is it to a negative power? Yeah, and that's what your brain's going to want to do. Because you're going to start getting to, you're like, I just seem to always rename them as fractions. But I only rename them as fractions when what? What's the reason? Right? What's the reason I rename them as fractions?
Only when the power is
Only when the power is negative. Is p being taken to a negative power?
No.
No, so we're not going to mess with it, are we? Cameron, how are we going to write it?
Just P cubed.
But then we'll make it into a fraction so that it can be multiplied times the other, right? Sometimes we make them into fractions, we didn't change them, we just are making them into fractions by putting them over 1 so that they can become part of a fraction multiplication. Okay, anything that you want to simplify first before you multiply? Anything that can go into something up that can also go into something down? Trey, you got something? No? Okay, so we're going to multiply, aren't we? 3 times 1? 3 times p cubed?
3p cubed.
3p cubed over 4 times r squared?
4r².
4r squared. 4r squared times 1?
4r².
4r squared. Notice I was feeling pretty confident, I already circled it. Because we already decided earlier nothing could be divided in up or down, so I'm feeling pretty good that they can't do that. I'm seeing positive exponents, not seeing any 0 exponents. I don't see any fractions within my fraction. So we're done with that?
Yes.
Okay, let's go to the back side then. Now we need to evaluate again, or we substitute in whatever they want the variable to be or variables to be, and then we follow the order of operations and apply our properties we know. So we're going to substitute first. So they want when z is 2. So we're going to put 2 in for our z, take it to the negative 5 power. Do we do that with a calculator? No. What would the calculator most likely, it doesn't mean you can't have your calculator set otherwise, what would the calculator most likely give it to you as? Shamarki, what do you think your calculator would do if we put it in right now, to the negative 5 power? In fact, would you guys get your calculators and try it? You're also supposed to be bringing them every day, remember? 2, and we were talking about knowing how to raise to a power, so would you find out what is 2 to the negative 5 power?
0.03125.
0.03125 is what Brighton's has, okay? Let's hear some from some others. Come on, and you
Oh,
can do
I
this.
got it. Mine says
So if you want to have
103.
calculators again,
Mine says 132.
yours takes it to the fraction. What a nice calculator.
I like it.
Okay. 0.03125, did that happen to anybody else or only Brighton? Okay. So that gives you the decimal answer. Does that mean that's wrong? No, it's just another name for 2 to the negative 5 power. So we're going to though, what do we have to show that we know what we're doing? Stefan?
You put it in fraction.
Okay, I'm listening to Stefan.
You put it in fraction, so it will be 1 over 2 to the positive 5 power.
Okay? And 2 times 2
4,
times 2
8,
times 2
16,
times 2 one more time.
32.
32. 1 over 32. And that's what Isaac's calculator says because Isaac's calculator is kinder. Yeah. Okay. And he's just got it set to do that. That's all. 1 over 32. So the value of z to the negative 5 power when z is 2 is 1 over 32. Is 0.03125 the same as 1 over 32? Do they live at the same place on the number line?
Yes.
Yeah, they're just different names for the same location on the number line. You know, it's way over here, pretty darn close to 1. Okay, but just this is the way I want you to give it to me. Okay, 4 plus y in parentheses to the 0 power. What do they want y to be? They want it to be 6. Okay, 4 plus 6 to the 0 power.
1.
4 plus 6 is,
10.
we're following order of operations, 10 to the 0 power.
1.
And that is 1. Okay,
It's still gonna be the same. Isn't 10 supposed to be in parentheses?
the 10 can be in parentheses, but doesn't have to be because we combined them. So that kind of got rid of the parentheses, and since it didn't turn out to be a negative number, we should ditch the parentheses. Okay, but you can have them there too, it doesn't hurt anything. Okay, anybody else, any concerns? Here, let's substitute for this one. We have 3/4, and we're going to put in a number, so we're going to have to put the 8, but since this is a fraction, when you suppose we should do with that 8? Put it over 1, and then raise it to the negative 2 power. Okay, multiplying fractions, what is it we like to do sometimes? Let's just rewrite it over here. 3/4 times 8 over 1 raised to the negative 2 power. Don't worry about that negative power yet. We're going to follow order of operations till we're ready to deal with that negative power. So what can we do when we keep asking this about when there were variables involved? What can we do? Instead of multiplying first, we can look to see if we can simplify first. Is there anything that goes into something upstairs and down, Isaac?
4.
4. Okay, so we're going to take 4 into itself, it's 1. We're going to take 4 into 8. What's that become?
2.
2.
6.
So we have anything else we can do? Well, we just got 1s downstairs, so we're going to say, okay, it becomes 3 times 2 is
6.
6, and over 1, so it becomes 6. It's not a negative 6, so we don't have to worry about parentheses. And now what? What would be our next step? Ariel?
Make it into a fraction.
Make it into a fraction. And what would that fraction look like?
1 over 6 squared.
1 over 6 squared. So these are all steps you have to show. Okay? So stay with me here. Make sure you're showing them so you have good notes to use when you're working. And 1 over 6 squared is what class? 1 over
36.
36. And there's our final answer. Okay. Why don't you try 11 then now on your own? Go. By the way, when there's 3 fractions, it's still the same rule for simplifying. If you get something to go into one of the numerators, that can also go into one of the denominators. You only have to do it to one, up and one down, even when there's three fractions involved. Okay, who's got their powers memorized? 15 to the second power, no calculator. I want to know who knows it without it. What is it, Isaac? Did you use your calculator, Isaac? Then you don't get to say. Who knows what it is without their calculator? Brighton? 225. 15 squared is 225. We're going to learn some of our powers. We're going to get these memorized. So if you're done, you can look to see if your work and your answer agree with mine. Okay. So any questions on that one at all? Anything we? So it's going to be a lot. So notice, you're going to make it a lot easier, really, if you substitute first, get all of it down, simplify down to, like here we end up with 15 being taken to the -2 power. Because otherwise, what would the properties we've learned before say? You'd have to take 5, give it a -2 power. Times A, give it a -2 power. Times B, give it a -2 power. So you'd have 3 things to the -2 power that you'd have to deal with. You have to get that simplified. Then you would insert into your answer there what you want A to be and what you want B to be. And trust me, it'll be more challenging. It'll be more work, actually. So do the substituting and simplifying that down first, and then deal with the exponents that are left, okay? So let's do this one. 10 is going to stay 10. And what are we putting in for x?
10.
10. So 10 is being raised to the -2 power. And what are we putting in for y?
-2.
-2 to the -4 power. Tell me what I didn't do that I should have done. What did I not do that I should have done? Rose? For where? Which one has to have parentheses? This one has to have. There's no option there. No option there. Okay, now I can do, I don't know how much room I think you got quite a bit of room left in your paper, right? Now I can do 10. Does that need to be renamed, by the way, 10?
No.
No, but I'm going to put it into a fraction by putting it over
1.
1. What am I going to do? Do I need to rename 10 to the -2 power? Right?
1/10 to the second.
Okay, we're going to make that 1/10 to the +2 power. Do I need to rename -2 to the -4 power?
Yes.
Stefan?
1/parentheses -2 to the 4th power.
Okay. Parentheses still needed there. Stefan was right. Don't you leave those parentheses off. Well, I think we're going to do this again. 10/1 times 1/, what's 10 squared, class? 100 times 1/, -2 times -2,
4.
4. 4 times -2,
-8.
-8. -8 times -2.
-6.
Negative is a positive. Positive times a negative is a negative. Negative times another negative is a positive. By the way, when it's an even number exponent, your answer will always be positive. When it's an odd number, it will always be negative. Okay. Can we do anything now before we multiply? So I'm going to do it here so that I can see what I had before I started crossing things out. Why don't you do the same thing so you have nice, good notes. Write it again, and then let's do some simplifying before we multiply. Josh, what can I do?
10 can go to 10 rows and go to 1.
Yeah, and remember, it only has just once up, once down. Even though we got 3 fractions here, that does not matter. Just once up, once down. Anything else we can do? Can we do this? Can we say, well, 2 goes into 2 and 2 goes into 16? Why not, Malcolm? I wasn't sure, your exercising your brain, or you're saying no to me. Can we do that? Can we take 2 into itself and 2 into 16 and simplify that way? What do you think, class?
No.
No, because they're both on the down, they're both on the same floor. One's gonna be up, one's gonna be down. Okay, so yes, Brighton? So the answer is, or did you have a question? Okay, what's your question?
Wouldn't 10 go into 110?
Oh, not 2 times, thank you, good catch. Way to go. How many of the rest of you were sitting there wondering why I said 2? Josh, you didn't even say that to me, I bet, did you? I know, sorry. Okay, how many times go in there, Josh?
10 times.
10, okay. Okay, now, can we still simplify though?
No.
Okay, they're both even numbers, but that doesn't matter. 1 times 1 times 1,
One.
upstairs, and downstairs, 1 times 10
And
times 16.
160.
160. And that can't be simplified, because we did all our simplifying before.